So, what is logic? That is the fundamental theme that we're trying to convey to you. We come across logic in our everyday lives all the time. And whatever we have learned so far, and when we discuss and argue about things in everyday life, at the back of the mind is some kind of logic that we have learned over time. Now, coming to the AI part or computing part of this, logic is a basic component of computer science. It is primarily concerned with the truth of the statements. It is a thinking process that reasons about things, about situations, about statements. Okay. And as I said, we are used to it in everyday life all the time. For instance, if I say it is raining, immediately your mind will start thinking, and you might want to turn around at the window and look out and see whether it's raining or not. So, what have you done? You're actually trying to determine whether it is actually raining or not. And for that, you have performed certain action. It is sunny, for instance, likewise. Once again, you will, if I say it's sunny, you will actually think about it and you might agree or disagree. You also know certain facts about life, like sun always rises from the east. It sets in the west. Okay. Canary is a bird. Parrot is a bird. So all of these statements, really, we actually come across every day. And the reasoning about it, the thought process, thinking that goes around with it, about these statements, is what we call as, logic processing. Okay. And that's what CS is all about, and that's what AI is trying to do. So let's consider another situation. We say that all horses have 4 legs. Now, you know this already, right? And if I say that a dog called Secretariat is also a horse called Secretariat is also a horse, you will automatically come to the conclusion that Secretariat has 4 legs. Nobody has said anything, but your mind has actually gone behind and analyzed and concluded some information. This conclusion is what we call as a valid deduction. So the first 2 statements, that all horses have 4 legs and Secretariat is a horse, these are 2 statements, what we call as premises. And the third conclusion that you've come across is that it has 4 legs, is a conclusion. Now, this conclusion is technically called a valid deduction, provided that this conclusion is true in every situation in which the premises are true. Okay, those premises, the first 2 statements. So in logic, what we do is we try to logic with the reason about the truth value of these statements or sentences. Okay, so you would say, as I said, if it is raining, you will say, yes, this statement is true. And if it is not raining, you will say the statement is false. So a sentence or a statement, as I just said, can have 2 values. Okay, it is either true or false. Logic must also define the semantics or the meaning of the sentences. And semantics defines the truth of each sentence or the statement with respect to the situation, what we call as a possible world. So when I said it's raining here or it is raining, what I'm saying is it is raining where I am talking from. You may be sitting elsewhere, and in your possible world in your situation, that may not be true. So you could say it's false, but I will say it is true. Okay. So, for example, in the semantics of arithmetic, okay, there's a sentence which says x plus y equals to 4. Now, in this situation, this is true in a world where x is 2 and y is 2, or x is 1 and y is 3, or x is 3 or y is 1. In each of these situations or the worlds, okay, this sentence will remain true, but it will become false where x is 1 and y is 1. Okay, so what I'm trying to highlight is that we are talking about the truth of these statements, true or false. However, very interestingly, these statements are allowed to have only two values, a true or a false situation, like rain or sunny or day or night and so forth. You cannot have, both situations at the same time. There's no in between. It is either raining or it's not raining. It is either day or night. Okay, so you can say it is either true or false, but a statement or a sentence cannot have both true and false. They cannot be true and false at the same time. Interestingly, again, as we move along, we'll come across something called fuzzy logic, where we do allow, partial truths, okay, partial degrees of truth, but we'll come to it when it comes to it. Okay, now before moving on, I just want to highlight a new concept, which is that of an agent. An agent is something that perceives its environment through sensors and acts on those. Like human beings, we are agents. We are intelligent agents. We have 5 sources of input or sensors coming in. Okay, and then we have a brain. We reason about those things, and then we take decisions. What we try to do in AI is to create artificial agents. By artificial agents, I mean we create, let's say, a computer program that has X number of sensors. It has a reasoning mechanism like we have in our brain, and then it takes decisions based on the situation that it comes across. Okay, so what we're trying to do is actually build intelligent agents. And likewise, they are called rational agents as long as they perform according to the environment and the application of reasoning mechanisms. An agent has mental capabilities like we do. It has memory, it has knowledge, it believes in something, and so forth. All right, so having said that, let's see what we want our agents to do. We want our agents to think and act like humans. We're trying to copy human behavior. And in doing so, the agents must be able to take decisions based on the situation, as I just mentioned. Okay? And it's pretty normal behavior, happens all the time. There are reasons for selecting certain decisions. And in general, in normal life, when you take a decision, you also explain, you define why you took certain decision. Why did you take a right turn? Why didn't you go straight? Okay, and other things which happens every day, all the time. So an intelligent agent must be able to provide reasoning or justifications for those decisions that it takes, just like we do. And it's only possible if it has the capability of understanding logic, like we all do. I'm going to discuss next 2 basic types of logic. Okay, one is called deductive logic. Deduction is a word in diction. If you go and look it up, deduction means to infer, to conclude, to reason based on certain principles. Okay, so deductive reasoning is what I'm talking about. For example, you say that all members of my family, they like to eat yogurt. This is a general statement, okay? And then you can say, all right, Ahmed is a member of my family. This is a specific piece of information. And you can reasonably conclude that since Ahmed is part of my family and my family likes to eat yogurt, you can reasonably, with certainty, say that Ahmed likes to eat yogurt. And likewise, as I said before, about the horses. So you have all horses, they have 4 legs. Secretariat is a horse, and therefore you can conclude, you can deduce, you can infer, okay, that Secretariat has 4 legs. And as I said, the first 2 statements are premises, and the third one, which is your conclusion, is a valid deduction as long as all horses have 4 legs and Secretariat remains a horse. Okay, so let's look at some basic characteristics of deductive logic. Number 1, complete evidence is provided about the truth of the conclusion made, and specific and accurate premises that lead to a specific conclusion. There's no ambiguity, everything is very, very clear, no ifs and buts. So the conclusion is definitely certain if your premises are true as you put them out to us. For instance, expert systems, in expert systems, like a doctor, you prescribe certain drugs, okay, which are accurate based on the information provided, okay. And then, of course, you provide explanation as well. Why did you prescribe a certain medicine? And there's a logic reasoning behind that. The next type of logic that I'm going to discuss is called inductive logic or generalization. What does it mean? Generalization is opposite to deduction. This really means that you generalize based on some limited knowledge. Okay? So we still start with premises and come to a conclusion. Okay? However, the result, the induction, okay, the conclusion itself is only probable. It's not certain, as in the case of deductive logic. And the reason conclusion in this case, in generalizations, is probable because it is based on limited number of premises or statements. Okay? And the more premises we add, those statements, 4 legs, and that's a horse, colors, and whatever. Okay? So the more things you add, the statements you add, the more probable the conclusion becomes. Okay? You could say that in induction, in generalization, the truth of the premises does not guarantee the truth of the conclusions, as in the case of deductive logic. Okay? So, for example, if you want to generalize, you say every salesman tries to lies, let's say, to make more money for a sale. That's not always true, but a general impression. Okay? A homework is very easy. Somebody could say that. But is it always easy? No, it's a generalization based on certain limited information. Or you could say homework is very hard. In some situations, that may be true. Okay? So these are generalizations based on a small set of truth statements. So therefore, the conclusion is probable. Okay? The rain in Spain falls mainly on the plains, a very famous statement. Okay? Is it always true? No. And in any case, it's a generalization. All right, moving on. So logic representation, algebra, for example, is an arithmetic formal logic. Propositional logic and predicate calculus are the next 2 types of formal logic that deal with these propositions. And the 2 basic ones are propositional logic and predicate calculus, sometimes also called first order logic. Right, thank you very much.